This is Mr. Rendrick coming at you from the 101 with my period 2 class. I'm going to talk about binomial and geometric probabilities using the Texas Instruments Inspire. This class is brought to you by Texas Instruments for all your calculator needs. All right, so let's get started. Now, in the first one, what type of model is happening in number 1? It's geometric. We are waiting. In number 1. Now, in number 1, though, I'm not asking you to find a probability. I'm asking you to find what? An expected value. Very good, Roberto. Or a mean, or an average. All those things mean the same thing. All right, now the formula for the expected value with a geometric model is 1 over your probability of success, or P. All right? What is our probability of a success in this problem? 0.11. So I'm going to write 1 over 0.11 and get 9.1 donors. Now, we have a blood drive at this school, I think. Did we have one last year? Yeah, we've had it every year since I've been here. And if we had one this year, like when we have it, and before we had anyone give blood, we're expecting which person to give us our first type B blood? The 9th. The 9th or the 10th. Will that happen? No. Could it be the 3rd person? Could it be the 17th person? But if every high school in a 25-mile radius from our school did a blood drive and calculated their number, and they gave us that information, all right, so Milby said it was the 11th person was type B. Chavez was the 6th person was type B. Everyone gives us the number, and I take the average. I expect that average to be around 9.1. That's an expected value. Questions? Oh, yeah. Okay. Number 2. What type of model is happening in number 2? Also geometric. This is waiting again. But for this problem, I'm asking for a probability. All right? So I'm going to write down the formula, the probability that our capital X, which is our random variable, in this problem for geometric, that stands for when are you getting your first success? When are we getting our first success? The 10th person. So I'm going to write 10. Now the way we do this is not type B, not type B, not type B. How many people in a row are not type B? 9. So I'm going to write down my probability of failure, which is 0.89. That's the probability of a failure to the 9th power times my probability of success. Questions about that setup, that work? I expect to see that if we're doing something where I'm grading your work. Okay? So does the AP exam. Equals. What do you guys get when you put this into the calculator? 0.04? 0.039? 0.038? Is it rounded to 9? It does? Okay. All right. So we're saying there's about a 4% chance that the 10th blood donor will be your first type B. All right, now let's move to the calculator. Can we move to the calculator, please? Excellent. So in the calculator, if you're doing this by hand, just a calculate page, letter A, I would have done 0.89 to the 9th power times 0.11. All right, so 0.039, it does. Excellent. All right, now, you guys ready for this? I don't think you are. Right? Menu. You ready for this? Menu. We've never done this before. Menu. Probability. Probability. Distributions. Now you see how there's a few up there you recognize, but I want you to keep going down. Is that Jay Sean in the background? Yeah, it was. No one's giving me any shout out for Jay-Sean there, right? 2006. Really? Somebody just said, baby, are you down? That's Jay-Sean, right? I mean, come on, guys. Somebody? No? At least Kevin's like, yeah, I think that's right. That was you singing? All right, cool. Do you know that I know the rap to that? All the words? Yeah. No. You haven't deserved it yet. Okay. I scrolled down a bunch to the letters. Do you see the letters? And you should see geometric. But there's two of them. What in the heck? Now, PDF and CDF. We actually have used these before with normal models. Remember the normal CDF and normal PDF? Here's what I tell students. If it's an exact number, I want you to use PDF. If there's a range of numbers, like at least or no more than, then you're going to use CDF. Okay? Now, what are we using here? It said the first type B donor will be exactly the 10th one. Correct? So I'm going to use geometric PDF, which is letter F. What is the probability of success? 0.11. What is our random variable equal to when we did our work? We said x is equal to 10. Because it was the 10th person. Wasn't the 10th person that was our first success? We're still there. We're still on this guy. Okay. It's the same answer. Hey, one person. Thanks, Eduardo. Trying to make up yesterday. I never forget. Unless I do. Now, here's what I usually tell students. Because when I was your age, and my teacher ran through this, rest in peace, Mr. Polk. When my teacher ran through this, I asked Mr. Polk, I said, Mr. Polk, that seemed like a lot more work than just using the calculator, like just typing in myself. And he said, absolutely. What I tell students is I usually don't use the geometric function. I just have them type it in. Okay? So you don't have to use the geometric function if you don't want to. All right? Questions on this? George?
So that was for number 2, right?
We're still on number 2. I have not gone to number 3. I'm sorry. Did I make that clear? I was just showing you how to do this with the Nspire using number 2.
Comes up, does that mean it's the same thing?
Nothing comes up. You didn't get all of that? Did you hit OK or cancel?
No, I hit enter.
Hit enter? Did you hit enter on cancel?
No, I don't.
Try it again. We'll wait for you. Any other questions? Everybody good?
Yes.
Okay. I'm going to move to number 3. So back to number 3. Now, number 3 is what type of model? What model is happening in number 3? This is binomial. This is binomial. Okay? Binomial. So the formula we use here is the probability of our capital letter X, which is something different when you use the binomial model. This is the number of successes. How many successes is it saying is happening in number 3?
2.
Exactly 2. So X equals 2. So I'm going to write 0.11. How many donors are type B blood? 2. So squared times my probability of failure, that's 0.89. How many of these people are not type B? 18. All right. Now, here's where it gets that extra step to get the right answer. The reason it's not just this is because if you calculated this probability would be for the answer of what is the likelihood that the first 2 out of 20 are type B donors. Does it say the first 2?
No.
No, it just says 2. So it could be the first and the last, the 4th and the 7th, 15th and 18th, right? It doesn't matter. So that's why we had to include yesterday something called a combination, where we have 20 donors, and how many are we choosing to be type B? 2. Now I saw George started doing this work. He started doing 20 factorial and writing, he wrote out 20. Can I show it? I mean, he wrote it out. All right, for those of you at home, you can't see it, but he did it. You have to trust me on this one. That's why you subscribe. You trust me. Okay? He started doing it, and he got that look on his face that most students get when they start doing that, and it's just like, I don't want to do this anymore. And I'm telling you right now, don't do it. But do I need to see all of this work? Yes. And now at this point, I'd write equals and move to the calculator. All right? So here we go.
So it's pointless.
Not pointless. Menu. Did you get it, Tanya? Did you end up getting it? Excellent. Menu. Probability. Distributions. Scroll all the way down. What model are we using? Binomial. Are we saying exactly or at least or no more than? What are we saying? Exactly. So I'm using binomial PDF, which is letter D. So I'm going to hit letter D. How many trials are there? 20. What is our probability of success? 0.11. Now, do you guys see where it says X value? It says optional there, but I always tell students, write in the number. How many successes do we want? Exactly 2. If you didn't put anything, what do you think it's going to do?
Oh, the first 2.
No. It's going to do 1 success. 1 success. Yeah. Because if you didn't do it, it'd do 1 success. Default, exactly. But I tell students, even if it is 1, put in the 1. Right? Get in the habit of putting it in. All right? So hit OK. And you have your answer. 0.282. 0.282 is the likelihood that we get exactly 2 out of 20 donors that have type B blood. Question so far using the Inspire. It's new stuff, guys. New stuff. That's why we are recording, so you can look at it again. All right, like, subscribe. Let's do number 4. Number 4. The probability that at least 2 of the first 10 donors have type B blood. At least 2 of the first 10. What is this? Geometric or binomial? Geometric or binomial? What is it? It's binomial. We have a number, that's not how you spell binomial. We have a number of successes. I know it looks a little weird because what is the number of successes? At least 2. So I'm going to write the probability that our capital letter X, our random variable, which is the number of successes, is greater than or equal to 2. Would you agree that that means at least 2? 2 or more. Okay? How are we feeling so far? Now, if it says at least, you guys are going to get, as I was telling students, you're in luck. You don't have to show any work. You just got to do the answer. Okay? So, let's go to the calculator. Menu. Probability. Distributions. Let's scroll down. We want binomial, but are we saying exactly 2 out of 10? What are we saying in this problem? At least. So that's 2 out of 10, or 3 out of 10, or 4 out of 10. So I'm going with this all the way up to 10 out of 10. All right, which is why I don't make you show the work, because you can imagine the work you have to do for all of those. You've got to do the 2, the 3, the 4, all of them. All right, so I'm not going to make sure the work. Maybe on Friday, if I'm feeling up for it, I'll show you what it looks like, just for fun. All right? I know, that little teaser before Friday. Come to school, right? It's a school day. All right, so which binomial are we going to use? CDF, because it's a range. All right? So I'm going to hit letter E, binomial CDF. Number of trials, 10 donors. Probability of success. Probability of success, 0.11, right? That hasn't changed yet. Now here we have lower bound and upper bound. What is our lower bound? 2, right? At least 2 means including 2. And our upper bound, well, what's our max? If we only have 10 donors, that's 10. All right? So then this is something you could do if it said no more than 6. What if it had said no more than 6 out of 10? Then what will be your lower bound? 0. Upper bound? 6. See the difference there? Okay. Hit OK. 0.303. 0.303. Questions? Questions on number 4 and using the Nspire? Now, if you're at all curious, and you can say I'm not, I've also posted, or I'm going to post a video of doing this same process, but using Excel. All right? Because although I really enjoy using this calculator, and I think it's a great calculator, what's more practical for your life is Excel. Okay? Which is one of the reasons that next year we're not going to use these calculators. We're going to use Excel. Okay? So if you're at all interested in what this looks like on a computer, take a look, watch that video. I do it with Excel.
What about on the IT stuff that everyone's looking
No, unfortunately not. So we're just not going to do APs. Like, subscribe. Sponsored? Oh yes, we're going to continue using Texas Instruments products until I'm no longer here. We will absolutely, and I will do my very best to buy all the products. Please pay us lots of money and products.
Use code Brandrick.
Code French. I like it. Okay, what are we doing? Number 5. You got time, right? I'm not sure, that's not true, but I like where your head's at. I think it's probably 2:15, 2:14. That was close. 2:14. Okay, we got time.
It's always practice there.
Always time, except when it is not.
Oh, yeah, you're right.
Okay, who wants to read this for me? Great, Marcelo. Read number 5.
Blood drive has a total of 150 donors. Assuming these are typical number of donors for a school blood drive, what would be the mean and standard deviation of the number of donors who have type B blood?
Excellent. All right. Now, when I look at this one, what I first want you to write down is that I want you to think about this as a binomial model. Okay. And in your notes from yesterday, there is a formula for finding the mean and the standard deviation for a binomial model. What is the mean? N times P. Well, how many people are at our blood drive? 150. So that's our N. And how many do we expect to be? Or what's the probability of these that we expect to be type B? 0.11. So what is 150 times 0.11? What is it? 16.5. Confirm, anyone? 16.5? Excellent. Now, can we have half a donor?
No.
No. Okay? We can't. We can't have half a donor. All right? Can't have half a person. So when we say this, it's okay to say 16.5 because this is a statistic. Okay? It's a calculation. It's okay that it has a decimal. We're saying we expect there to be 16.5 donors that have type B blood if 150 people donate blood at our gym. Is that going to be true? Could it be more than 16? Less than 16? Absolutely. That's what we're expecting. Okay, that's what we're expecting. Now, what about the standard deviation? The square root of N times P times Q. So if we plug that in, that's the square root of 150 times 0.11, but they've added another thing on here, times 0.89, which is our probability of failure. So what is our standard deviation for this binomial model? Say it again? 3.83. Confirm, anyone? 3.83? Yes, 3.83. Thank you. Not every 4. We're saying that for that 4 number or 3.83 number, it means that we expect if we did this a bunch of times, that we would have a mean that's no more than about 4 away from 16.5.
Oh.
Right? So if somebody said, hey, we did at our school, we did 150 donors, but we actually got 75 people that have type B blood, that is, like, plus 4 is about a little over 20, plus 8, it makes it 25, 70, that's a lot compared to what we're expecting. All right, that's getting into number 6. Let's talk about number 6. Now, I spoke about this yesterday in our lecture, that you have Bernoulli Trials. Think of Bernoulli Trials as the clock, okay? And then if it's a tree coming down from the clock, we have 2 different models. What are the 2 models we talk about? Geometric and binomial. Those are both Bernoulli Trials. They're not like one or the other. They're both Bernoulli, but we have 2 different types, one for weighting and one for number of successes. But I told you yesterday that the binomial one, all right, can actually end up morphing into what? The normal model, if we check something. And it's called the success-failure condition. Here's what it means. If we do n times p and n times q and get 10 or more, we actually have enough of a sample size that we can use the normal model instead of the binomial. Which means we can draw a bell curve, guys. We can look at 3 standard deviations above, 3 standard deviations below. We can use 68, 95, 99.7 rule, all that stuff that we talked about in October. So, what is n times p? Oh, we already did it. Did you guys see it? We already did it. 16.5. Is that 10 or more?
Yeah.
Absolutely. What is n times q? So 150 times 0.89. What's n times q? Or what's 150 minus 16.5? 133.5. Is that 10 or more? It is. So do we have a large enough sample that we can go to the normal model? Yes, we do. Yeah.
Isn't it 10% though?
What do you mean 10%?
So like, I thought it was like 10% of like the overall. So out of 150, would it 16% be less than 10%?
I think what your brain is thinking about is the 10% condition, which is something different. If you thought that each donor was not independent of the next one, like at our school, do you think there's any issue if everyone in our school decided, not everyone, but if people from our school decided to give blood, would you think that there's an issue with independence? Anyone? Do you think there's an issue of independence if we had only people who work here or go here donate blood? I know there's an issue. Marcelo's an issue. Why is Marcelo an issue? He has a sister that goes here. Do you think there's a higher chance that they have the same type of blood? Yes. Also a problem for you, George, right? See what I'm getting at? So if you're worried about that, then what you ask yourself is our 150, let's say, how many people you think are on campus, like, if all the students were here? 500 and what, 550? And all the teachers and staff and everyone? What do you think, we're 650 max? Okay. As long as the number of donors at our school does not eclipse 65, then our sample is less than 10% of everyone that's here. So I wouldn't worry about the fact that you guys have people that are related to you at the school. That was a long explanation, but that's where I'm worried about the 10%. This 150, where is it? 150. If this 150 is because it's at a big public high school that has 4,000 people on the campus, then that's way less than 10%. I'm not worried about independence. Everybody good? That's a great thought. Great thought. Okay, so it says in this problem, gotta go fast. How many type B blood donors would it take you to convince you that the 0.11 estimate is too high? Now, this is a really confusing problem. It's asking, is this 11% too high? Which means that we would need to see actually less type B donors at our high school blood donation or blood drive. Okay? So when I do my curve for the normal model, all I care about is going to the left. So what's right in the middle? Which is 16.5. Very good. What's one standard deviation below 16.5? What's 16.5 minus 3.83? What is it?
12.67.
12.7?
67.
Great. I know it's 6.7. I'm just rounding. It's all good. What's 12.67 minus 3.83?
8.84.
8.84. And what's 8.84 minus 3.83?
5.01.
All right. So I know I can't raise it up, so I'm sorry it's so low trying to see it. When did we talk about, or when we talked about this in September, October, when did I tell you that things became unusual when it came to the normal model? When did things become unusually high or unusually low? When they went what? When they went past what? The bell curve. It went past what? Past 3 standard deviations above or 3 standard deviations below. So look at 3 standard deviations below. So if they tell me at their high school they had 6 people that had type B blood, is that past 3 standard deviations below? Is that past 3 standard deviations below? No, 6 is not less than 5. So when I'm asked the question, how many blood donors that have type B, that would make me worry about this 11% being too high, I'm saying less than 5. If their blood drive has less than 5 type B blood donors, then I'm worried about that 11%. But if it has 5 or more, you're good. You're still within our model here of being not unusual.
You can't say more than like 16.
So if it had flipped the question and said, maybe they think this is too low, then I would have gone that way, above the 3. So 1, 2, and 3 above. So it's a weird, we're going to do more, because it's a weird kind of question to understand in your brain. Because it's like, they're saying they think the estimate's too high, but you got to think then the number's too low. Okay? All right. Thanks for listening at home. Hope you guys enjoyed the video. And like and subscribe, and I'll see you next time. We out. That's it.